Hello everyone, I'll be doing question 2 of the 2016 AP Physics C Mechanics. Okay. So, the block of mass 2m is at rest and there's no friction, which means this is just force normal and 2mg. Because this thing isn't moving vertically, however there is the force of gravity and the force of normal, and it's not moving horizontally and there's no force applied, so yeah. 3m, so this one has velocity, but don't get tricked when an object has velocity. Velocity is not a force, which means this one's still just, we can make this one a little bigger. Force normal and 3mg. So just because an object has velocity doesn't mean there's a force applying horizontally. Okay, so that'll be it for question A. Question for B, derive an expression for the blocks immediately after the collision. So this, when they talk about collision, it mainly uses like energy and momentum. So as we know, they do collide together. This is an inelastic collision. So that means the blocks are sticking together, which means we just have to add the masses up. So as we know, P initial is equal to P final. And the equation for momentum, this is on your equation sheet, is P equals mass times velocity. So that is your momentum equation. So if we take our initial momentum, which is just going to be the mass 1 of V initial 1, I'll write it like the initial one, plus m2 v2 initial is equal to the total masses of 1 plus 2 v final. So we're just going to plug everything in. So then this would be, as we know, this is at rest. So that would be 2m at 0 velocity, just cancel out 0, plus m2, which is 3m v naught. And we're going to add the masses. 3 plus 2 is 5, 5m, v final, and we just solve for v final, which is just equal to 3 over 3 times m v naught, 5m, which is just 3 over 5 v naught. And this is your answer. Okay, moving on to part C. This is also very straightforward. Kinetic energy equation is just 1/2 mv squared, and we just have to replace everything. So 1/2 mv squared. The total mass for the 2 block system is going to be 2 plus 3, which is equal to 5m. And the velocity is just what we solved for right here, because they're asking for the kinetic energy immediately after the collision, and we just solve for the velocity after the equation, or the collision, sorry, not equation. 3/5 v naught, whole thing squared. So what is this? 945, 45 over 50 m v naught squared, which is equal to 9 over 10 m v naught squared. That's your answer for the expression of kinetic energy. Part D. Okay, so we're going to use the work energy principle theorem. Work is equal to change of kinetic energy, because we're only dealing with kinetic energy and spring energy. So this is also going to be the change, or the integral, of the force dx. And this is pretty much all in your equation sheet, so if you ever forget. So up here, they did mention an equation, f of x is equal to negative bx cubed. So we're going to use that equation and plug in our kinetic energy that we just solved for right here. 9 over 10, m v naught squared, which is equal to the opposite of 0 to d f, which is negative bx cubed dx. So why is it opposite? Well, if you look at the direction of motion and like the displacement, that's why it's negative. And why is it 0 to d? Well, the initial displacement is 0 because the spring is at, like, it's relaxed, it's at rest, and it moves a displacement of d, as we can see from this. It's at 0 and it moves to d. So that will be our equation. So now cancel these negatives out and we integrate 9 over 10 mv0 squared, which is equal to, we can just take out this b because it's a positive constant, as mentioned up here. I believe it's b is a positive constant. So then you just take out the constant, x to the 4th divided by 4 to 0 to d. And then we just solve. So that'd be 9 over 10 mv0 squared. Remember FTC, which is like f of b minus f of a, as the integration limits go from a to b. So this would be d to the 4th divided by 4 minus 0 to the 4th divided by 4, and 0 is just 0, right? So that means we're just left with b times d to the 4th divided by 4. And all we have to do is solve for d now. So that we're going to multiply this over. So d to the 4th is equal to, so multiply 36 m v0 squared, divide the b, 10b, and we can to the 4th root, which is 4th root 36 v0 squared, 10b, and just to simplify it, we can do 4 18 v0 squared 5b, and that is your final answer. Okay, now moving on to the next part. I'm going to, we can just do it over here. In which direction is the net force, if any, blah blah blah, the block of the spring is at a maximum compression. Okay, so if this, so the spring force is always trying to go back to the wherever equilibrium is. So equilibrium is like right here, and the block is like right here. So it's going to go back to this point. The block is going to try to move to that point. So when the block is at its maximum compression, so the spring is really coiled up right now, and it is, and this was the equilibrium position, the block is going to do everything in its, or the spring, sorry, is going to try to move the block back there. So this would be to the right. And you just have to explain that. The force, I think just saying like the force of the spring moves back to equilibrium, and the equilibrium is to the right of maximum compression, or something like that. So, and then which of the following correctly describes the magnitude of that force? Okay, so this would actually just be 3m. So, as we know that this is what a diagram would look like. So, the force spring, and then this is block 2m and block 3m. So, maybe some people would tackle this problem saying that, oh, but 2m has the force of 3m and the force of spring applying on it. However, that's not, that is true, but that doesn't mean it has the greatest force, because as we know that the blocks are sticking together. So if the blocks are sticking together and moving together, that means their acceleration is the same. So if we look at the equation F net is equal to ma, if both, let's write this as 2m and 3m. So let's say they said net force, right? So this would be 2m and acceleration, and this would be 3m and acceleration. And as we know, their accelerations are exactly the same because they're connected to each other and moving exactly the same. So we don't have to care about this a. So 2m or 3m, that's what we're left with. And as we know, 3m is definitely bigger. So that's why the mass of 3m has the greater net force. And do the two blocks remains. Okay, so to exhibit simple harmonic motion, we need something. The force has to be equal to negative or x, something like this. It has to be a linearized equation. Like, it basically just has to follow something in this form. However, if we do look at the equation, I believe it was negative bx cubed. It is not linear. This is cubic, which means this is no. All you have to say is that this simple harmonic motion is not simple harmonic motion because the force is cubic. And that will be it for question 2. Thank you for watching.